Hello and welcome to our today's lesson. In this lesson, I'm going to work on exercise 3.1 of Cambridge Primary Mathematics Workbook 5. And in this exercise is about counting in sequences. On the first part of this exercise, we have a worked example. In this worked example, it says, Marcus counts back in eights, starting at 50. Now it says, what is the first negative number Marcus says, and how do you know? Answer is given in two different ways. The first one says 6 jumps of 8 is 48. So after counting back 6 lots of 8, Marcus says 2. So the next number Marcus says is negative 6. The other way that is answered here is, it says, another way to think about this question is, each term is 2 more than a multiple of 8. So 10 is 2 more than a multiple of 8, and if you count back in 8s, you get to 10, then 2, and then negative 6. So this is the other way that's answered here. So I think there's no need for more explanation over here because the explanation is given in details here. Let's now straightforward go to question number 1. In question number 1 of exercise 3.1, it says, what is the next number in this sequence? Sequence, you know, is a series of numbers that follow a rule. Now here it says, what is the next number? We have 8, 6, 4, 2, 0, and the other number that we don't have. How can we find this number? If we look closely to the numbers, 8 is subtracted by 2. Then 6 is subtracted by 2. 4 is also subtracted by 2. So 8 minus 2 is 6. 6 minus 2 is 4. 4 minus 2 is 2. 2 minus 2 is 0. And 0 minus 2 is negative 2. Now it says, how do you know? We can say that we can get by subtracting 2. If we continuously subtract 2 in each term, so we can get to negative 2, which is the last number in this sequence. Well, question 1 is done. Let's move to question number 2. In question 2, it says, this is an 8 by 8 number grid. 8 by 8 number grid. Part A says, color multiples of 7. Multiples of 7, you know, are the numbers we get by multiplying 7 with other numbers. The first multiple of 7 is 7. The second one is 14. Then 21. Then 28. 35. 42. 49. And 56 over here. And the final one is 63. 63. Part B says, what do you notice? What we notice here, the multiples of 7 make multiples of 7 diagonal line. The multiples of 7 make diagonal line. Here also it makes diagonal line, and over here also it makes diagonal line. Well, in part C it says, let me scroll a bit down. In part C it says, if you continued the sequence, would 100 be an 8? No, 100 cannot be a multiple of 7. We can say no, because 100 because 100 is not a multiple. 100 is not a multiple of 7. How do we know? We know that 10 times 7 is 70. And 3 times 7 is 21, which gets us to 91. And 91 plus 7 is 98. 98 plus 7 is 105, which cannot give us 100. That's why 100 is not in the multiples of 7. So question 2 is also done. Let's move to question 3. Let me scroll a bit down. Okay, in question 3 it says, this pattern makes a sequence. It makes a sequence. You count the squares in each row of the staircase. You count the squares in each row of the staircase. The sequence starts at 1, 3, 5. Complete the table. Complete the table. Here we have 1 square, then we have 3, then 5. After 5, we will have 7. So the fourth one is 7. The fifth one is 9. The sixth one is 11. And the seventh one is 13. The seventh one is 13. How can we get? So we have 5 here. If we include 2 more here, then it will be 6, 7. Each time we increase it by 2. Then if we increase it by another 2, if we increase it by another 2, we will have 9. And by another 2, we will have 11. And the same way, we will have 13. So in part B, it says, continue the sequence to show your result. So we have 1, 3, 5. We have 7. We have 9. Each time we add 2. We add 2. So 1 plus 2 is 3. 3 plus 2 is 5. 5 plus 2 is 7. 7 plus 2 is 9. 9 plus 2 is 11. 11 plus 2 is 13. 13 plus 2 is 15. And 15 plus 2 is 17. What is the term-to-term rule? Here in part C says, what is the term-to-term rule for this sequence? So the rule is add 2. Add 2. If we add 2 each time to the sequence, we get the next number. We get the next number. Well, we are done with question 3. Let me scroll down to move to question number 4. In question number 4, it says, a sequence starts at 19. 9 is subtracted each time. What is the first number in the sequence that is less than 0? Less than 0. So let me write it down. 19 minus 9 is, okay, 19 minus 9 is 10. 10 minus 9 is 1. 1 minus 9 is negative 8. So the first number in the sequence that is less than 0 is 8. Question 4 is also solved. Let's now move to question number 5. In question number 5, it says, Zara counts back in steps of equal size. In steps of equal size. Write the missing numbers in her sequence. The missing numbers in her sequence. Over here, she starts from a number and she reaches to 61, then 52, then maybe another number, and then finally 34. We can see that each time she subtracts 9. 61 minus 9 is 52. 52 minus 9 is 43. 43 minus 9 is 34. So what number is subtracted by 9 to get 61? For sure it is 70, and the previous one is 79, because 79 minus 9 is 70, and 70 minus 9 is 61. So we are done with question number 5. Let's now work on question number 6. In part A of question 6, it says, here are some patterns made from sticks. Draw the next pattern in the sequence. So we have the first one is having 6 sticks, the second one is having 11 sticks, and the third one is having 11, 12, 13, 14, 15, 16. It's having 16. Each time 5 sticks are added to the pattern. So the fourth one will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. This is the fourth pattern. As it's asking us to draw the next pattern, so we found the fourth one, which is having 21 sticks. Let me scroll a bit down to move to part B. In part B, it says, complete the table. Pattern, number of sticks. The first one is having 6 sticks. The second one is having 11 sticks. The third one is having 16 sticks. And the fourth one is having 21 sticks. So here in the pattern, each time we add 5 sticks. Now it says, find the term-to-term rule. The term-to-term rule is add 5. Add 5. Each time we add 5 to the next pattern. Each time we add 5 to get the next pattern. Well, let me scroll down to move to part D of this question. In part D, it says, how many sticks are in the 10th pattern? In the 10th pattern. We know that we have 6 sticks in the first pattern. 6 sticks in the first pattern. So to get the 10th one, we can add 6 by 9 times 5. 9 times 5. 9 times 5 gives us 9 patterns plus 6, which is the first pattern. So 9 times 5 is 45. 45 plus 6 is 51. So the 10th pattern is having 51 sticks. Let me show you how we can do it so. Over here, the first pattern is having 6 sticks. So the second pattern is 6 plus 1 times 5. 6 plus 1 times 5 is 11. 1 times 5 is 5. 5 plus 6 is 11. The third one we can get by 6 plus 2 times 5. So 2 times 5 is 10, and 10 plus 6 is 16. And the fourth one we can get by 6 plus 3 times 5. 3 times 5 is 15, and 15 plus 6 is 21. It is 21. In the same way, to find the 10th one, we can add 6 by 9 times 5. 6 plus 9 times 5 gives us 51, which is the 10th pattern. Well, we are done with question number 6. Let's now work on question number 7. In question number 7, it says, a sequence starts at 400 and 90 is added each time. 90 is added each time. 400 plus 90 is 490. 490 plus 90 is 580. 580 plus 90 is 670. Actually, if we add 100 to 400, it would give us 500. But we have 10 less than 100. Each time, 10 less than 100. So if we have 490, to get the next one, we add 100 and then we reduce it by 10. So 490 plus 100 is 590, but if we take away 10 from it, it will be 580. So the same way, 580 plus 100 is 680. Then if we take away 10 from it, we will have 670. So the next one or the next pattern is if we add 100 to 670, we will have 770. But we will have 760 if we take away 10 from 770. Now here it says, what is the first number in the sequence that is greater than 1000? Greater than 1000. So each time we increase by 100 and the tens decrease by 10. The hundreds increase, the tens decrease. So the first number that we get, let me continue. We will have 850, 940, and 1030. So the first number is 1030. As I said, the hundreds increase by 1 and the tens decrease by 10. So from 60 we get to 50, from 50 to 40, and from 40 we get to 30. So the first number greater than 1000 is 1030. Well, question 7 is also solved. Let me scroll down to question number 8. In part A of question 8, it says, draw the next pattern in the sequence. Draw the next pattern in the sequence. So in the first pattern, we have two shaded hexagons. So we have 3 here, 3 here, 3 here. 3 plus 3 is 6, and 6 plus 2 is 8. 8 plus the other 2 is 10. Here we have 10. Let's count here. So we have 4 here, 4 here, 8, and 3 here. 8 plus 3 is 11. 11 plus 2 is 12, 13. It means to get from this pattern to this pattern, we have to add 3 hexagons. Here we have to add 3 hexagons. Let's count here. 1, 2, 3, 4, 5. If 5 here, 5 here, 10, 10. 10 plus 4 is 14, 15, 16. So here we have 16 hexagons. Again, from the second pattern to move to the third one, we added 3 hexagons, so we got the third one. Now, if we want to move to the next pattern, which is the fourth one, we should have 5 hexagons in the center. Let me draw it. Okay, 1, 2, 3, 4, 5. 5 hexagons in the center. So we have to complete this. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And 1 here. It will be 6. Then here 7. Then we have to follow the same way down here. Okay, 1, 2, 3, 4, 5, 6, and 1 here. Well, 7. How many do we have now? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. We have 19 hexagons over here. So 10 here, 13 here, 16 here, and 16 plus 3 will be 19 hexagons over here, which is the next one. Part B says complete the table. Pattern number, we have number 1, number 2, number 3, number 4, and we have numbers of hexagon. In pattern number 1, we have 10 hexagons. In pattern number 2, we have 13 hexagons. Number 3, we have 16 hexagons, and number 4, we have 19 hexagons, which is now done. So in part C, it says, find the term-to-term rule. The term-to-term rule over here is add 3. Each time if we add 3 hexagons, we move to the next pattern. Well, in part D, it says, let me scroll a bit down. In part D, it says, how many hexagons are in the 8th pattern? In the 8th pattern. Well, the same way that I explained in the previous sequence, here also, the first one is 10 hexagons. So to find the 8th one, we have to multiply 7 by 3, because each time we add 3. So 7 times 3 is 21, and 21 plus 10 is 31. So the 8th pattern is having 31 hexagons. Well, question number 8 is also done. Let me scroll down to move to question number 9. In question number 9, it says, Sophia counts in threes starting at 3. Sophia counts in threes starting at 3. So if she counts, she has 3, 6, 9, 12, then 15, 18, and so on. But Zara counts in fives starting at 5. If she counts on, it will be 5, 10, 15, 20, 25, 30, 35, and so on. It says they both count on what is the first number greater than 100 that both Sophia and Zara say. The first number more than 100 that both Sophia and Zara say. That number is 105. Why? Because we know 10 times 3 is 30. So 30 times 3 is 90. Again, if we count on from 90 and 3s, we will have 93, 96, 99, 102, and 105. The same way, 20 times 5 is 100, and 21 times 5 is 105. So 105 is the first number that both Sophia and Zara say, and that number is more than 100. Here it says, explain your answer. I already explained 105 is the only number that both Sophia and Zara say after 100. After 100. Well, this is the answer to question number 9. Let me scroll down to move to question number 10. In question number 10, it says, Zara writes a sequence of 5 numbers. The first number is 2. The last number is 18. Her rule is to add the same amount each time. To add the same amount each time. Write the missing numbers. So we can have some possible numbers. If we add 4 to 2, we will get 6, then we will get 10, then we will get 14, and then we will get 18. That's good. So the number that we can add is 4. 2 plus 4 is 6. 6 plus 4 is 10. 10 plus 4 is 14, and 14 plus 4 is 18. So the same number that she adds is 4. Each time she adds 4 to the previous number to get the next number. This is the answer to question number 10. In question number 11, it says, Arun writes a sequence of numbers. His rule is to add the same amount each time. Write the missing numbers. Write the missing numbers. So we have to add a number. Each time we have to add a number to get 2 other numbers and finally reach to 40. Again, let me try with 4. Negative 1 plus 4 is 3, and 3 plus 4 is 7. 7 plus 4 is 11. It does not reach to 14. Let me try with 5. Negative 1 plus 5 is 4. 4 plus 5 is 9. And 9 plus 4 is 14. So 5 works here. If we add 5 here, 1 plus 5, negative 1 plus 5 is 4. So 4 plus 5 is 9, and 9 plus 5 is 14. So we are done with question number 11 also. This is the last question of exercise 3.1 of Cambridge Primary Mathematics Workbook 5. I hope it helps you learn how to find the related answer to questions which are about sequence and also counting numbers on and counting numbers back. If it helps you, please make sure to subscribe to my channel, like the video and share the video with your friends, your classmates, and if you are a teacher, share it with your students as well. Have a nice time and thank you so much.